Hi, Assalamualaikum. Madam Ruby here. Let's learn Chapter 5 Chemical Bonding by continuing Lewis structure covalent bonding for lesson 23. Today we are going to draw covalent bond and dative bond involving single, double and triple bonds, comparing their bond length, and also stating the exemption to octet rule. We are going to draw a lot of Lewis structures for covalent compound. The smallest covalent compound ever is the hydrogen gas. What does each of the hydrogen atoms shares? Do you know what it is? Yes, they share electrons. Covalent bond is formed by sharing one or more pairs of valence electrons between the bonded atoms involving non-metal atoms. For example, for our hydrogen gas just now, each hydrogen atom is going to provide one electron for sharing. So there's going to be 2 electrons in the bonding pairs. Atoms other than hydrogen tends to form bonds until it is surrounded by 8 valence electrons. We call them octet or noble gas configuration. For hydrogen, it will form duplet, if you still remember from last lesson. Lone pairs are something else. They are the pairs of valence electrons that is not involved in covalent bond formation. They are 3 types of covalent bonds, which is single, double, and triple bond. Let's look at it one by one. A single bond is formed when 2 atoms are held by one pair of electrons. Let's say we have fluorine gas. Each of the fluorine atom has 7 electron valence, and each of them is going to provide 1 electron for bonding. What is going to happen is, in the covalent compound, fluorine will be surrounded by 8 electrons now. So they are going to form noble gas configuration, complying to the octet rule. Shown to you here are the 3 lone pairs belonging to each of the fluorine atom in the covalent compound. A double bond is formed when 2 atoms share 2 pairs of electrons. For example, for carbon dioxide, the central atom carbon has 4 electron valence. So it is going to form a double bond on the left side and on the right side. Each of the oxygen atom is going to have 8 electrons surrounding it to comply for octet rule, and the central atom carbon also has 8 electrons surrounding it. All of them are the bonding pairs. Triple bond is formed when 2 atoms share 3 pairs of electrons. For example, here we have the nitrogen gas, which will provide 3 electrons each for the bonding and the formation of triple bond, whereby we can see each of the nitrogen atom has 8 electrons surrounding it. Single bond has the highest bond length, followed by double bond, whereas triple bond has the lowest bond length. Table 5.2 is showing the comparison of the bond length in picometers. So let's look at the single bond between carbon and carbon. It's 154 picometers. This is longer than the double bond, 133. and the shortest bond length is the triple bond, which is 120 picometers. Let's do example 5.3 in your page 129. The covalent compound in the question is HCl hydrogen chloride. Show the formation of covalent bond in the compounds below using the Lewis structure through equation. 3 marks. So you need to draw hydrogen atom with 1 electron valence, chlorine atom with 7 electron valence, and together they will make up a covalent compound with 1 bonding pairs of electron. Another example is for fluorine gas. You know, each fluorine atom would have 7 electron valence, and together they will become F2 with 1 pair of bonding electrons. Dative or coordinate bond is a covalent bond formed when only one atom can provide both electrons of the shared pairs. Please write this example 5.4 in your page 130. Hydroxonium ion H3O+ is formed when the oxygen atom in H2O water provide both of electrons to form covalent bond with H+. As you can see on the right structure, the electron bonding pair is represented by the red arrow from oxygen to hydrogen. Please take your time to do these 2 questions on your own first, as we are going to give the answer in the Telegram channel soon. Now let's look at the exceptions to the octet rule now. There are 3 anomaly situations: incomplete octet, expanded octet, and odd number electrons. What are they? Incomplete octets occur when central atom has less than 8 electrons. Certain atoms such as beryllium, boron, and aluminium cannot achieve octet configuration. For example, in example 5.5, you have to write down the examples for beryllium hydride having 4 valence electrons surrounding it, aluminium chloride having 6 electrons surrounding it, and finally boron trifluoride having also 6 valence electrons surrounding the central atom. The fourth compound in example 5.5 is beryllium dichloride. Beryllium shared electron with chlorine, forming 2 single covalent bond, but in beryllium dichloride, beryllium atom only have 4 electrons in the outer shell. This means that it does not achieve octet configuration. It only formed incomplete octet. Now, what is expanded octet? First, we need to know that the atoms of element from period 3 onwards may have more than 8 valence electrons in their compound. This is due to the existence of empty d orbitals that can be used in bonding. An example of expanded octet is sulfur hexafluoride. Sulfur as an atom has 6 electron valence. Fluorine as an atom has 7 electron valence times 6 is 42. Combined together, total is 48 electrons. So you can see around sulfur there are 6 electrons, which is going to form 6 bonding pairs with 1 electron from fluorine each. we are going to have 6 bonding pair. 6 times 2 is 12. And every fluorine atom has 3 lone pairs. 3 times 6 is 18 lone pairs. Times 2 is 36. So we come back at the total of electron 48. Our Lewis structure is correct. The third exception to the octet rule is odd number electrons. This is due to the presence of odd number of electrons around the central atoms. For example, the compound nitrogen oxide. Nitrogen has 5 electron valence and it will form a double bond with oxygen. But it is going to have only 7 electrons surrounding it because it is an odd number electrons configuration. Now let's learn how to draw the Lewis structure of covalent compound step by step. First step is you need to draw the skeletal structure of the compound. Put the most electropositive element in the center. Second step is you need to count the total number of valence electron for each atom and add 1 electron for each negative charge, subtract 1 electron for each positive charge. The third step is complete an octet for all terminal atoms except hydrogen because it's duplet. And the last step is if the structure contains too many electrons, you can form double and triple bonds on the central atom as needed. For example 5.8, let's draw the Lewis structures for the following compounds, one by one. Okay, let's start doing the first molecule. The first molecule is nitrogen trifluoride. Nitrogen trifluoride. So the question asks you to draw the Lewis structure of the compound, not the formation. So we can just write the nitrogen in the middle because it is more electropositive than fluorine. We want to draw the skeletal first. Fluorine would be surrounding nitrogen. Nitrogen has how many electron valence? 5. So 1, 2, 3, 4, 5. Okay, these are the dots that I want to represent as the electron valence for nitrogen. And then fluorine has how many electron valence? 7, right? So 1, 2, 3, 4, 5, 6, 7. Another one for fluorine. 1, 2, 3, 4, 5, 6, 7. واحد اثنين ثلاثة أربعة خمسة ستة سبعة. So here we go. This is the Lewis structure for the compound NF3. So if we want to cross-check whether our Lewis structure is correct or not, we want to count the number of electrons for nitrogen as an atom is 5 electrons. And fluorine, we have 3 of them. Each has 7. So 7 times 3 is 21 electrons. The total is 26 electrons, right? Okay. When it becomes a compound, we are going to calculate the bonding pairs of electron. How many are there? 1, 2, 3. So there are 3 bonding pairs times 2. 3 times 2 is 6. Okay. And the lone pairs, do you remember what lone pairs are? They are the ones that are not involved with bonding. So each fluorine atom would have 3 lone pairs. 3 times 3 is 9. 9 times 2 is, oh, I forgot. There is another one here. So it is 10. So 20 electrons. There are 26 electrons altogether. We have the correct answer. Yay! The second compound in example 5.8 is ammonia, NH3. So we know that nitrogen has 5 electron valence and we have 3 hydrogen. Voila! That is your covalent compound. So let's count the electrons. Nitrogen as an atom has 5 electrons. 3 hydrogen atoms has 3 electrons. Total together is 8 electrons. How many bonding pairs do we have? 1, 2, 3, right? So 3 times 2 is 6. And how many lone pairs do we have? Just 1, right? So 1 times 2 is 2. We have the total of 8 electrons is the same as this one. So we have the correct Lewis structure for the compound ammonia. Let's do the third compound, carbonate ion. If we have the 2 negative charge, it means that we have 2 extra electron in the polyatomic ion. So we put carbon in the middle. This is the skeletal first step. Carbon in the middle is because it is more electropositive. How many electron valence does carbon has? 1, 2, 3, and another one would be here so that it can form a double bond with this oxygen. Oxygen has 6 electron valence, so that's just nice. What about the other 2 atoms of oxygen? 1, 2, 3, 4, 5, 6. Oh, we have room for 1 extra electron here. And the other oxygen, 3, 4, 5, 6, another extra oxygen over there. So we have to draw a big square bracket here, and we have to tell that we add 2 electrons inside. So basically, this is the Lewis structure for the carbonate ion. Well done. The fourth compound is ammonium ion. Ammonium ion, as we have drawn earlier, has dative bond. So let's show where is the dative bond inside the ammonium ion now. So nitrogen atom would be in the middle. We have 1, 2, 3, 4 hydrogens surrounding nitrogen atom. So we have 1, 2, 3. Where is another 2? Here. 1 and 2. This is the dative or coordinate bond whereby nitrogen provides 2 electrons for covalent bonding with this particular hydrogen. This hydrogen has its own electron. This one has 1 electron. This one has 1 electron. So notice that hydrogen will achieve duplet, but nitrogen will achieve octet. So finally, we draw a big square bracket with a plus in it because we lack of 1 electron from the hydrogen here. What if we want to draw the arrow that represents the dative bond? That's how you draw it. Exactly like this. So the arrow basically represents the 2 electrons initially belonging to the nitrogen. So now we draw the square bracket and the charge. This is how you draw the ammonium ion. Thank you. Okay, finally, the last compound that we have to draw is the nitric acid, HNO3. Right. HNO3 is basically coming from or ionized partially to become H plus and NO3 minus. So let's draw the nitrate ion first. So N would be in the middle, oxygen would be surrounding it, and we have 1, 2, 3, 4, 5 electron valence for nitrogen. Oxygen, we have 1, 2, 3, 4, 5, 6, and 7. This is where the extra electron is. Okay, and then we draw the dative bond here. So we need to move this one over here. So now I'm going to delete this electron over here. Okay, now this is the electron valence for oxygen, 1, 2, 3, 4, 5, 6. And then we are going to also form a double bond over here. 1, 2, 3, 4, 5, 6. Oh, I forgot to remove this electron. Okay. Now, what happened is we want to put the H plus now. The H plus will be situated over here. Because this extra electron here actually coming from the hydrogen atom. So there you go. This is the structure of a nitric acid. You have 30 molecules of covalent compound which you have to draw. Start with these first 13 molecules in 8 A4 pages. Thank you very much for listening and see you again soon. Bye.